Okay, Rams, we are now on page 59 and 60 in your notes. We're going to work on prime factorization, and part of this goes back to what you've already learned in 5th grade. So, what is a prime number? Well, a prime number is a number whose only factors are 1 and itself. Okay, so what we're going to do is we're going to color or highlight all of the prime numbers that we see on this hundreds chart, okay? It's important that we know them and we have them here, okay? So I'm going to start with, I would say 1 because the only numbers are 1 in itself. 2 because the only factors are 2 and 1. 3 is prime. 5 is prime. 7 is prime. 9 is not. Most of the prime numbers are odd, but 9 is not because 3 times 3 and 1 times 9, okay? So 11, 13, 17 is prime, 19 is prime, 23 is prime, 29 is prime, 31, 37, 41, 47, 53, is 57 prime? Yes. All these weird 7s are. That's funny. I'm going through thinking about the numbers, thinking about their factors here. 61. I'm trying to remember these off the top of my head here. I think I missed 59 and 79. Okay. 81. Let's see. 83 is prime. 87 is, I believe, prime. 89. 91. 97. Those should be, I believe, all of your prime numbers up to 100, okay? And we can double check it too. All right, so how do you determine if a number is prime or composite? Well, we just need to find its factors. Okay? And what I mean by that is what numbers go into it. So this is something you learned in elementary about factor trees. Okay? So when you make a factor tree, we start with what multiplies to go into it. So 42 is made up of 6 times 7. So the 2 branches here are 6 times 7. I always put a multiplication symbol in the middle, okay? And then 7 is prime, so I circle it. 6 is composite because 2 times 3 equals 6. Now 2 and 3 are prime. So we're going to write the prime numbers from up here. We're going to write 2 times 3 times 7. Okay, your answer is this right here, but you have to write your numbers numerically. So we put them in order, least to greatest here. And if they're listed more than once, we'll write it with an exponent. And we'll show you that in a second. But right now, that is your answer. Okay, a lot of times when I say show the prime factorization, I get a factor tree, but I don't get the actual answer. This is the answer because 2 times 3 times 7 is 42. Okay? All right. So now we're going to go over here to the number 72. Okay? So what numbers make up 72? The first ones that come to my mind are 8 times 9. So I'm going to say 8 times 9. It's important to put the times there, okay? You could choose other numbers. You could use 12 times 6, 36 times 2. You could choose other things, but these are what I chose, okay? Now, 8 is made up of 2 times 4. 2 is prime, so I circle it because that's the only thing that goes into 2 is 1 times 2, okay? 4 is made up of 2 times 2. They're both prime. I'll put my multiplication symbols there. 9 is made up of 3 times 3, and they're both prime. My answer is not done, okay? So what I'm going to have to do is go over here, and I'm going to write my numbers in numerical order. 2 times 2 times 2 times 3 times 3. Okay, now there are 3 2's, so I'm going to write 2 to the 3rd power times, and then there are 2 3s. I'm going to write 3 to the second power. So the only difference between the 5th grade level of this and the 6th grade level is that in 5th grade we write it with no exponents, and now in 6th grade we write it with exponents. We write it one step farther, okay? Okay, now 48. What do we want to choose? I think 6 times 8 sounds pretty good. 6 times 8 is 48. 6 is made up of 2 times 3, and they are both prime. 8 is made up of 4 times 2. 2 is prime, and 4 is made up of 2 times 2. So right here, my answer, I'm going to have 1, 2, 3, 4 2s and a 3. So it'll be 2 to the 4th power times 3, and this is your final answer. Okay? 50. What do you want to have 50? I think 5 times 10 sounds good. You could also do 2 times 25. That's okay. As long as it's 2 numbers that multiply. Don't put 25 and 25. A lot of people do that because they're like, oh yeah, 25 and 25 make 50. Well, not by multiplication. 25 times 25 would be 625, okay? So be careful with that. 5 is prime. 10 is made up of 2 times 5, and they're all prime. So my answer here would be 2 times 5 times 5. Have to look at all the numbers I circled. So 2 times, and then there are 2 5s. So that's my final answer. Okay, 45 is made up of 9 times 5. 5 is prime. 9 is made up of 3 times 3, and they are both prime. So 3 times 3 times 5, which is also the same thing as 3 to the second power times 5, and that is my final answer. Okay? Now, your reflection question over here says, how do you know when you are done factoring in the factor tree? How do you know when to stop? Okay, when you have reached prime numbers. Now, what happens a lot of times is that you'll see like a problem like this right here, and that it would say, what is the prime factorization? People may put like 9 times 5. Well, 9 isn't prime. Your numbers have to all be prime, okay? Your numbers have to all be prime. Okay, now be sure and write your summary. Thanks, Rams.